November 1969. Apollo 12 has returned to orbit. The lunar module ascent stage, now empty, its mission complete, is released on a trajectory that will send it crashing into the surface of the Moon. This is deliberate. NASA has placed seismometers on the lunar surface specifically to measure what happens when something hits it. The ascent stage strikes. The seismometers register the impact. And then, something unexpected happens. The Moon keeps vibrating. Not for seconds. Not for minutes. For 55 minutes. One of the NASA scientists present described it this way: "The Moon rang like a bell." That description appeared in NASA's own documentation. It has never been fully explained to everyone's satisfaction, and it was only the beginning. Hard Truth Science, Episode 5, The Moon Rang Like a Bell. What people believe, the hollow moon hypothesis and why it exists. The hollow moon hypothesis has been around in various forms since at least the early 20th century. In its most extreme version, the claim is that the Moon is an artificial construct, a hollow shell placed in orbit around Earth by an intelligence we have not identified. This version is not what we are examining today. It is not scientifically serious, and we will not treat it as such. What we are examining is something more specific and considerably more interesting: the documented scientific anomalies in our understanding of the Moon that led serious researchers, including NASA scientists, to use language like hollow and to publish papers raising questions about the Moon's internal structure that have not been fully resolved. The hypothesis gained its most credible foothold in 1970 when two Soviet scientists, Mikhail Vasin and Alexander Shcherbakov, published an article in Sputnik magazine titled "Is the Moon the Creation of Intelligence?" They were not fringe figures. Vasin was a member of the Soviet Academy of Sciences. Their argument was not based on speculation. It was based on data, specifically on 4 anomalies in the scientific record that they argued could not be adequately explained by conventional models of lunar formation. Those anomalies are real. Their interpretation is contested. The data itself is not. The 4 anomalies Vasin and Shcherbakov identified are worth understanding on their own terms. First, the Moon's density. The Moon's average density is 3.34 grams per cubic centimetre. Earth's density is 5.5. The Moon is significantly less dense than Earth. In fact, it is less dense than Earth's crust alone. This is unusual for a rocky body of its size and implies either a very different composition or a significant void space in the interior. Second, the core. Based on seismic data, the Moon appears to have an unusually small iron core, or possibly no core at all. Every other large rocky body in the solar system has a substantial iron core. The Moon is the exception. Current models describe a small, possibly solid inner core surrounded by a fluid outer core, but the data remains ambiguous. Third, the orbit. The Moon's orbit is nearly perfectly circular. This is statistically unusual for a captured body. Objects captured by a planet's gravity typically have elliptical orbits. The Moon's orbital eccentricity is 0.0549, close to circular by any measure. Fourth, the eclipses. The Moon's apparent size in our sky almost perfectly matches the apparent size of the Sun. This is why total solar eclipses are possible. The Sun is 400 times larger than the Moon and 400 times farther away. The match is within a fraction of a percent. Each of these has an explanation. The question is whether those explanations are complete. The hard truth. What the seismic data actually shows. The scientific pillar at the center of this question is the seismic data from the Apollo missions. Between 1969 and 1977, NASA placed 5 seismometers on the lunar surface. They also conducted a series of controlled impacts, deliberately crashing spent rocket stages and lunar modules into the Moon at known locations and velocities, to study how seismic waves propagate through the lunar interior. The results were, by any measure, unexpected. When the Apollo 12 lunar module ascent stage struck the surface on November 20, 1969, the seismometers registered vibrations that continued for 55 minutes. When the Apollo 13 Saturn V third stage struck the surface on April 14, 1970, in a much larger impact, approximately 2.5 times the energy, the vibrations continued for 3 hours and 20 minutes. For comparison, when seismometers measure impacts on Earth, the vibrations typically dampen out within minutes because Earth's interior is fractured, contains water and other fluids, and dissipates seismic energy efficiently. The Moon did not behave this way. The vibrations rang on and on with very little attenuation. This is what the NASA scientists meant when they said it rang like a bell. The scientific term for this property is low seismic attenuation, and it is the hard truth at the center of this question. Low seismic attenuation means that seismic waves travel through a material for a long time without losing energy. The question is, what kind of material does that? The answer, according to mainstream lunar science, is dry, cold, rigid rock with very few fractures and essentially no water or fluid content. The Moon's interior, unlike Earth's, is extraordinarily cold, dry, and rigid. Seismic waves bounce around inside it the way sound bounces around inside a large empty room compared to a room full of furniture. This is the accepted explanation. It is scientifically coherent. It does not require a hollow moon. But here is where it gets complicated. The seismic wave propagation patterns from the Apollo impacts were analysed in detail by researchers at several institutions throughout the 1970s. The data showed that seismic waves near the lunar surface behaved very differently from waves deeper in the interior. The outer layers scattered waves intensely, more than almost any known rock, while the deeper interior showed the extended ringing. A 1972 paper by Gary Latham and colleagues at Lamont Doherty described the lunar seismic signals as unlike anything previously recorded on Earth or in laboratory experiments. That characterization has not been fully overturned. The examination. What happened when researchers looked closer? The Apollo seismic network was shut down in 1977 due to budget cuts. The data it collected has been analysed by multiple research teams in the decades since. In 2011, a team led by Renee Weber at NASA's Marshall Space Flight Center published a reanalysis of the Apollo seismic data using modern signal processing techniques. Their paper, published in Science, described the Moon's interior in more detail than had previously been possible. They found evidence of a small solid inner core approximately 240 kilometers in radius, surrounded by a fluid outer core of approximately 330 kilometers. This is substantially smaller, relative to the Moon's size, than the cores of other rocky planets. The paper was widely reported as having resolved the question of the Moon's interior. In some respects, it had. But several things remained unexplained. The attenuation anomaly, the extended ringing from controlled impacts, was not fully addressed. The density deficit relative to other rocky bodies was acknowledged but attributed to composition differences rather than void space. And the origin of the Moon itself remains one of the most actively debated questions in planetary science. The leading theory of how the Moon formed is called the giant impact hypothesis. Approximately 4.5 billion years ago, a Mars-sized body called Theia collided with the early Earth. The impact was oblique, a glancing blow rather than head-on. Material from both Earth and Theia was ejected into orbit and eventually coalesced to form the Moon. This theory explains several things well: the Moon's angular momentum, the similarity of oxygen isotopes between Earth and Moon, and the Moon's relatively small iron core. Most of the iron would have already sunk to Earth's core before the impact. But the giant impact hypothesis has unresolved problems. Computer simulations of the impact struggle to produce a Moon with the exact composition we observe. The Moon is enriched in volatile elements that should have been vaporized in such a violent collision. Recent isotopic analyses have found that Earth and Moon are even more chemically similar than the standard model predicts. In 2012, a team at Harvard published a variant called the High Energy Impact Hypothesis, proposing that the impact was so violent that both Earth and Theia were vaporized into a disk of rock vapor. This explained the isotopic similarity but raised new questions about how the Moon retained its water content. As of 2024, no single model of lunar formation explains all the observed data completely. The honest conclusion: what the data says and what it does not. Let us be precise about what we know and what we do not. The Moon is not hollow in the way the most extreme versions of the hypothesis claim. The Apollo seismic data confirms a solid interior with a small but real core. No credible scientific evidence supports the idea of an artificial shell or engineered structure. The low seismic attenuation, the ringing, has a conventional explanation: extremely dry, cold, rigid rock with very few fractures. This explanation is accepted by the mainstream scientific community and is supported by the data. What remains genuinely open is more subtle. The Moon's origin is not fully explained. The giant impact hypothesis is the leading model, but it does not account for all the observed chemistry. Multiple competing variants exist in the active literature. The Moon's density relative to other rocky bodies is anomalously low, and its core is anomalously small. These are explained by reference to the impact origin, but the explanation depends on a formation model that is itself not fully settled. And the seismic data from the Apollo missions, 4 decades old, collected by instruments that were then switched off, has never been fully replicated with a modern permanent seismic network. The Lunar Geophysical Network, proposed multiple times since the 1990s, has never been funded. Here is the one thing that would change this conversation significantly: a permanent, modern seismic network on the lunar surface, multiple stations, modern sensors, continuous monitoring, would provide a complete picture of the Moon's interior that the Apollo data never could. The Apollo network ran for 7 years with instruments designed in the 1960s. Modern seismology could map the lunar interior in far greater detail. The Chinese Chang'e program has deployed seismic instruments on the lunar far side. NASA's Far-Side Seismic Suite, part of the Lunar Geophysical Network initiative, is in development. The data coming from these missions over the next decade will either confirm the current model in full or reveal something unexpected. What we know: the Moon rang like a bell in ways unlike anything previously recorded. The explanation given is scientifically reasonable. It has not been fully tested with modern instruments. What we do not know: exactly how the Moon formed, exactly what its deep interior looks like, and whether the anomalies in the Apollo seismic record are fully accounted for. The examination is still open. The data is still coming in. Hard Truth Science. The examination is still open. Follow us on YouTube at Hard Truth Science.